Hello everyone, welcome to the lecture 1 on basic electrical engineering. In this lecture, we will understand details about electric potential, resistance, law of resistance and resistivity. Imagine lifting water to the top of a tank. The higher the tank, the more energy the water has. Electric potential works the same way. Electric potential at a point means the electrical energy stored per unit charge because of its position in an electric field. It tells us how much work is done to place a unit positive charge at that point. Electric potential is the work done per unit charge in bringing a positive test charge from infinity to a point. Unit, volt, V. 1 volt is equal to 1 joule per coulomb. Voltage is the potential difference between 2 points in an electric circuit. It represents the energy per unit charge that pushes electric current to flow. Gravitational analogy. Water stored at a higher height has more gravitational potential energy, just like a charge at a higher electric potential has more electric potential energy. Water flows from high to low height. Charges move from high to low potential. Flow happens because of a difference. Height difference causes water flow, and potential difference, voltage, causes electric current. Point charge potential is the electric potential due to a point charge is given by V is equal to kqr. Here, K is Coulomb's constant, Q is the source charge, and R is the distance from the charge. This means, as distance increases, potential decreases. Now, potential energy is given by U is equal to QV. This tells us that the energy of a charge depends on the charge value and the electric potential at that point. So, potential tells the condition of space, and potential energy tells how much energy a charge has there. What is resistance? Resistance is the property of a material that opposes the flow of electric current when a voltage is applied. When electrons move through a conductor, they collide with atoms and ions. These collisions slow down electron motion. This opposition is called resistance. Mathematical definition from Ohm's law. R is equal to V by I, where R is equal to resistance, V is equal to voltage applied, I is equal to current flowing. Physical meaning. High resistance, electrons find it difficult to move means small current. Low resistance, electrons move easily means large current. Unit of resistance. SI unit, ohm. Definition of 1 ohm. A conductor has a resistance of 1 ohm if a voltage of 1 volt produces a current of 1 ampere through it. The resistance of a conductor depends on its physical dimensions and material. According to the law of resistance, at constant temperature, the resistance of a conductor is directly proportional to its length. Longer wire, more collisions, higher resistance, and is inversely proportional to its cross-sectional area. Thicker wire, more space for electrons, lower resistance, and also depends on the nature of material. For copper, silver, low resistance. For rubber, glass, very high resistance. Resistivity is a material property that indicates how strongly a material resists the flow of electric current. It is independent of length and area. It is expressed by ρ. ρ is equal to Ra by L, and unit is ohm meter. Good conductor has very low resistance, so electric current flows easily. Example, copper, aluminum. Insulator has very high resistance, so it strongly opposes the flow of electric current. Example, rubber, glass. Temperature affects resistivity. Temperature changes. Atomic vibrations, lattice vibration, number of charge carriers, collision frequency between electrons and atoms. These microscopic changes alter how easily electrons move, changing resistivity. Effect of temperature on different materials. A. Metals. Temperature increases, resistivity increases. Reason: higher temperature atoms vibrate more. More vibrations, more electron-atom collisions. Collisions reduce electron drift velocity, resistivity increases. Semiconductors. Temperature increases, resistivity decreases. Reason: temperature increase generates more charge carriers, electrons, and holes. Increase in carrier concentration dominates over collision effects. Net effect conductivity increases, resistivity decreases. This is all about electric potential, resistance, law of resistance and resistivity. Thanks for watching. Kindly like, share, and subscribe.